Today I'll be doing my final project for AP Statistics, and the activity I have is analyzing the caffeine experiment. In the experiment performed by Mr. Wilson class, the mean change in pulse rate for the caffeine group was 1.2 greater than the mean change for the no caffeine group. This provides some evidence that the caffeine increases pulse rates, and is this evidence convincing, or is it plausible that the difference of 1.2 would arise just due to chance variation in the random assignment? In this activity, we'll investigate by seeing what differences typically occur just by chance, assuming caffeine doesn't affect pulse rates. That is, we'll assume that the change in pulse rates for the particular student will be the same regardless for what treatment he or she was assigned. In part 1, we see gather 20 index cards to represent 20 students in the experiment. On each card, write one of the 20 outcomes listed on the table, which is this one right here. For example, write 8 on the first one and 3 on the second card, and as you can see, that's what I did over here. Now, the second part says shuffle the cards and deal 2 piles of 10 cards each. This represents randomly assigning the 20 students to the 2 treatments, assuming that the treatment received doesn't affect the change in pulse rates. The first pile of 10 cards represent the caffeine group, and the second pile of the 10 cards represent the no caffeine group. So we're gonna go ahead and shuffle the cards. And then we're gonna separate again into 2 groups. Two, 9, 10, 10 and 10. Now what we're gonna do is find the mean of both of the samples. So go to calculate. In order to find the mean, we add all the numbers and then divide them by the total amount. So it's -2 plus 2 plus 1 plus 5 plus 5 plus -1 plus 4 plus 3 plus 8 plus 3, and that's the first one, divided by 10, and that gives us 2.8 for the first one. So I'm gonna put a mean of 1. And for the second one, we do the same thing. 0 plus 4 plus 1 plus 6 plus 0 plus 4 plus 1 plus 4 plus -1 plus 5, have the 10th one, and then divided by 10, which gives us 2.7. So when we subtract this, 2.8 minus 2.7, and we have a mean difference of 0.1. Again. And that's the result for the second step. Now it says for the third step is to find the mean change for each group and subtract the means, which is what we already did right here. Okay, and then the next one says in Mr. Wilson's class, the observed difference in means was 1.2. Is the difference of 1.2 statistically significant? Discuss with your classmate. So in order to find that out, we have to do a state plan, do and conclude method. So what we have to do, we will put state mean 1 minus mean 2 equals the true difference in mean between students that were given the treatments caffeine and no caffeine. Okay, and then we will have a null hypothesis, which is mean 1 minus mean 2 equals to 0, and the alternative hypothesis, which is mean 1 minus mean 2 does not equal 0. And we have a significance level of 0.05. So for the plan, we know it's going to be a 2-sample t-test. And we have to check conditions. First random, and it clearly states that the sample is randomly assigned. So we put randomly. Of 20 students. We do the 10% rule, which both samples have 10 students, which is 10 times 10 is less than the total, which is the total amount of students, total number of students. Same thing with the second sample. And these both are correct. And then we do the CLT, which is a rule that the n has to be greater than 30, which in this case 20 is not greater than 30. So this tells us that the data will be unfair. And the do part, we have to put both samples, the things for both samples, which we know for the N1 it is 10, and the N2 it is 10 as well. The mean for N1 is 3.2, and the mean for N2 is 2. In order to find the standard deviation of both, we need to use spreadsheet. And in order to do that, we will go to the calculator, we go to spreadsheet, and we will plug in the numbers that we have in the chart, which is 8, 3, 5, 1, 4, 0, 6, 1, 4, 0. And we do another the other side. 3, -2, 4, -1, 5, 5, 1, 2, -1, 4. Go to menu, we go to statistics, and we put stats calculations, and we do 2 variable statistics. We put A, B, and the answer will pop up in C. And here we get the standard deviation, which is 2.69. So for the first one, 2.69. And for the second one, we get 2.62. So 2.62. The mean difference, we know that it is 1.2, and the equation is t equals mean 1 minus mean 2 over the mu over standard error. And to find standard error, we do the square root of standard deviation of mean 1 squared over n1 plus standard deviation of mean 2 squared over n2, and just plug in the numbers, which we know is 2.69 squared over 10 plus 2.62 squared over 10. And then from there, we know that is the standard error. So we put t equals 1.2 minus 0 over, and we solve for this. We go to the calculator. We put 2.69 squared over 10 plus 2.62 squared over 10, and we get 1.187